Hi, I'm a member of the Math and National Honor Society, and today I'm going to be going over exponential functions. So first, let's just discuss what an exponential function looks like. So an exponential function takes the form of y equals a times b to the x, where a is our initial value or our y-intercept, which is just when x is equal to 0. And our b value is essentially the base or the multiplier value. And so each time we increase x by 1, we're going to multiply by this value. In contrast, a linear function adds the slope value, but in this case, we're going to multiply by this base value. And so what's also important to remember with this base value is that uh, it can only be positive. It can't be negative. And if the base value is greater than 1, it represents exponential growth. But if it's less than 1, then it represents exponential decay. And so we'll see examples of both in the upcoming slides. What do these exponential functions actually look like? So in this example, we have y equals 2 times 2 to the x. So our a value or our initial value is 2, and then our b value or our base value is also 2. And so what this means is that our graph has a y-intercept at 2, so at x equals 0, y is equal to 2. And then every time we increase x by 1, we'll be doubling the value. And so we can see that each time we increase x, the value doubles. So at x is equal to 0, y is equal to 2, and then x is equal to 1, y is equal to 4, x is equal to 2, y is equal to 8. And so this just continues, so on and so forth. And then we can also see through this graph that this function is a exponential growth function because b is greater than 1, and then this results in this graph having this like upward curve, as we can see here. So for this next example, we have y is equal to 20 times 1/2 to the x. So 20 is our a value or our initial value, and then 1/2 is our b value or our base value. And so since this b value is less than 1, we know that this is an exponential decay function. And this is represented graphically through this downward curve as shown here. And so what this function essentially means is that we're going to be starting off with an initial value of 20, and then each time we increase x by 1, we're going to be halving it. So at x equals 0, we're going to have this initial value of 20, and then at x equals 1, we're going to have 10. X equals 2, we're going to have 5, and then x equals 3, we're going to have 2.5, and then this just goes on for infinity. And then this essentially just approaches this x-axis. And so what's important to note is that these exponential functions have a horizontal asymptote, as shown here. So what this means is that the graph will approach the x-axis, or when y is equal to 0, but it will never touch that. And so we can also see that in this previous example, that it approaches this x-axis, but it never actually touches it, because the value at that point is not necessarily 0, but it's just some very, very small number that's very, very close to 0. How do we actually go ahead and graph exponential functions? Let's just say we're given this exponential function equation, which is y is equal to 4 times 3 to the x. So 4 is our initial value, which is when x is equal to 0. And then 3 is our multiplier or base value, which means that each time we increase x by 1, our y value will be multiplied by 3. And so what we can do is we can just set up a table of values. So we'll just start off with x is equal to 0, and we know that's 4 from our initial value. And then instead of individually substituting in these x values and then going through the individual calculations, which can take some time, we can just multiply this y value times 3 to get the next y value. And so we know we can do this because our base value is 3, and we know that this base value is essentially a multiplier by which we multiply each y value to get the next y value. And so we can just keep doing this until we feel like we have a sufficient amount of values. And so 4 in this case is good enough because after 4 values, the y values start getting very large and then it becomes very difficult to graph. And so when we graph these points, we can see that, first of all, we start off at 0, 4, which is our initial value and our y-intercept. And then we go to 112 and then 236 and then 108. We're not able to graph on this scale, but if we were able to graph it, it would be somewhere up, all the way up here on this line. And so as we can see, this graph has an upward curve, which makes sense because our b value, or our base value, is 3, which is greater than 1. And we know that when it's greater than 1, that indicates exponential growth, which is an upward curve. And so let's just say we were given 2 coordinates and then we were told to solve for the exponential function equation. So the way we would go about this is that we would just first start off with our original exponential function, which is just y is equal to a times b to the x. And then what we can do is we can go ahead and then substitute the first pair of coordinates into this function. So once we do that, we get 6 is equal to a times b. And then we can go ahead and then substitute the second pair of coordinates in again. So what we get is 18 is equal to a times b to the 2. So as we can see here, we substituted 2 in for x. And so what we can do here is we can kind of factor out this b, and then we get b times a times b. And so we know that this is equal to 6 from substituting in the first coordinate pair. So we can just go ahead and then substitute 6 in for a times b. And then we get 18 is equal to b times 6. And then we can divide both sides by 6, and then we get b is equal to 3. And then that only gives us our b value. Now we have to go ahead and then solve for our a value, which is our initial value. So the way we would do this is that now we would take this b that we just found and we would substitute back in to the original equation, and then we get y is equal to a times 3 to the x. And then now we can just go ahead and substitute one of these coordinate pairs. So we'll just go ahead and then do the first one, 1, 6. And then we get 6 is equal to a times 3 to the 1, which is just a is equal to 2 after we divide both sides by 3. And so once we get our a value of 2, we can just substitute that back into the original equation, and then we get the final exponential function equation of y is equal to 2 times 3 to the x. And so to finish off this video, let's just finish with 3 practice problems. So please go ahead and pause the video and attempt these on your own, and then once you're done, you can unpause the video and then we'll go over these together. So now let's go ahead and go over the answers to these practice problems. So for number 1, we have 2 parts. We have part A and then part B. So part A asks, what is the initial value? So when we look at our exponential function, we know our initial value is the value without the exponent on it. And so in this case, the initial value is this one right here, and that's equal to 2. So our initial value is 2. And so what is the base value? So we know our base value is the number with the exponent on it. And so when we look at our function right here, we see that 5 has the exponent on it. So that means our base value is equal to 5. For number 2, we're asked to graph slash sketch y is equal to 3 times 2 to the x. And so the way that we would do that is that we could set up a table of values, and then we can go ahead and then graph based off that. And so when we do that, what we would get is that at x is equal to 0, y is equal to 3 because that's our initial value, and then we multiply that 3 by 2 to get 6 at x equals 1, and then we multiply that by 2 to get 12 at x equals 2, and then 24 at x equals 3, and then this results in like this upward curve which continues onward towards infinity, which is indicated by this arrow sign. And then when it curves this way to the left, it approaches this x-axis, but it doesn't touch it. So that's an important feature to remember when graphing exponential functions. And now number 3. So in number 3, we're given two coordinate pairs, and then we're asked to find the exponential function equation. So we're given 112 and then 3 192. So what we're going to do is we're going to start off with the initial exponential function equation, which is y is equal to a times b to the x. And then we're just going to substitute in the first coordinate pair. And so once we do that, we get 12 is equal to a times b. And then we're going to do the same thing with the second coordinate pair. And that gives us 192 is equal to a times b to the third power. And so after that, we can kind of factor out this b squared to give us a times b. And so we know that this a times b is equal to 12. So we can substitute in 12 right here. And then we get 192 is equal to 12 times b squared. And then we can divide both sides by 12. And then once we do that, we get 16 is equal to b squared. Once we square root both sides, we get b is equal to plus or minus 4. But since we know that the b value can only be positive, because the base can only be positive, we know that b has to be equal to 4, not negative 4. So with b is equal to 4, we can substitute that back into our initial exponential function equation, and then we get y is equal to a times 4 to the x. We can substitute in any one of these coordinate pairs, but I just chose 112, and then I got 12 is equal to a times 4 to the 1, and 4 to the first power is just 4, and then I can divide both sides by 4, which gives me a is equal to 3. So b is equal to 4, and then a is equal to 3. So now I can substitute these back into my original exponential function equation and then get y is equal to 3 times 4 to the x. And that concludes our video. I would just like to thank you all for watching, and I hope you were able to learn something useful from this video.